Hello, this is Sabir. The topic of our discussion in this video tutorial is permutation. Permutation is a particular case of product rule. Actually, product rule is a very general rule of counting. Almost all the real world problem can be solved by using the product rule. So in order to synthesize the product rule, in our coming few videos, we will discuss its particular case. So today we will discuss the case of permutation. What is permutation? The other meaning of this word permutation are arrangement, order, grouping, and sorting, etc. So a permutation is an arrangement of object, and this is a very special arrangement where we do not allow the repetition and also the order is being important. So there are two keywords, the repetition is not allowed and the order is being very important. So this is sort of the particular case of the product rule, because in the product rule we do not put these restrictions on the problem. So now let me first show you some examples so that we can better understand what is a permutation. Our first example is that how many way we can arrange the letter A, B, C. Since I have only three letters, I will write down the different arrangement of this. So I can write first A, then B and C. So this is a arrangement, or we can say this is a permutation. So now if we want to find all the permutation, we will basically try to see that how many way we can arrange the word A, B, C. So there is another arrangement I can see. I can write A first, C and B. Then I can write B here and then A and C. Then B, C, A. This is another arrangement. And then C, A, B. And then C, B, E. So you can see that there are total 6 different permutation, or there are 6 different arrangement of the letter A, B and C. So basically when we are looking into a permutation problem, what we are looking is basically we are trying to put the object into a line and then we want to shuffle them, and I want to find the different shuffling of how many different way we can shuffle these different object. So for example, there are two words again, the repetition is not allowed and order is being important. What their meaning here is that I cannot use suppose AAB. So this is not allowed in the permutation because you cannot use the same object twice. So repetition is not allowed. And also if I have all the objects same, so if I have two A and one B, so in this situation you will see that A permutation, this permutation, and if I switch this A with this A, I have the same permutation. So the order is important, and order is important when all the objects are distinct. So then automatically order will follow. But if you have the same object, the identical object, in those objects the permutation will not be able to calculate the total number of way, because there will be a some way which will be identical because the two objects are same. So you cannot use the permutation on those problem where you have identical object. But as long as you have a different object, you should be able to use the permutation. So now let's find out what is the formula and how fast we can solve this problem by using the permutation instead of using the product rule. So in order to calculate the formula, I would write down this problem in terms of like using a product rule, and then we will find out the formula out of that. So okay, if I want to find the total number of permutation by using the product rule, first I will write down what is the procedure. So as you can see, my procedure is I need to arrange. So the arrangement is the procedure. There are letter A, B, C. So if I want to arrange these letter A, B, C, next I will write down what are the tasks I have to perform in order to arrange them. As you can see, the first task I have to perform, I have to place the one letter in the first position. That's the first position. And then I need to place another letter in the second position. And then I need to place the third letter in the third position. So these are the three tasks I need to complete. Now let's find out how many ways we can complete each task. As you can see, the first task can be complete in three ways because there are three letters available we have for the first position. But once I use the first letter, then I cannot use the same letter in the second position. So this is the two way to do the task. And again, since the repetition is not allowed, so the third task only have one way to complete it. Next is we would like to find what is the conjunction. As you can see, these tasks are connected with the word and, because I have to complete all the tasks simultaneously. I have to place the character in the first place and the character in the second place and the character in the last place. So there are basically three tasks and three tasks has to be complete one by one. So therefore the total number of arrangement by the product rule will be 3 times 2 times 1, which is basically 6. So you will see the formula for this problem. I can generalize this formula actually. If I have three letter and I have to place these three letter into the three position, then my permutation is 3 times 2 times 1. And as you can see that if I have a 4 letter and I have to place in the 4 position, I have to find all the arrangement of the 4 distinct object, then it will be 4 times 3 times 2 times 1 by using the product rule, and so on. And similarly, I can say that if I have n object and I have to place into the n position, I can write this as a n, then the next position will be n minus 1, n minus 2, and so on up to 2 and 1, because I have to basically fill all the position. So the product rule will give me this number of permutation. So here is another notational form of writing this formula. So we can write 3, 2, actually it is a 6, but we can write it as a 3 factorial. So what is a factorial? Factorial is a notation of the product. So it start from where whatever the value is inside of that symbol factorial, and it is the product of all the natural number which are this number and less than up to 1. For example, this is a 4 factorial, so this is the product of 4, 3, 2, 1, so on. And in general, this is the n factorial. So this is our formula. If we have n object, we have to place into the n places, then the formula is n factorial. So this is the biggest takeaway from this example is that if you have n object, these are objects are distinct, and we have to place into n position. So we have to make the arrangement of length n. So all these shuffling can be calculated by using this formula, which is the n factorial. So let's do one more example. Here our example number 2 is how many ways we can arrange 4 people at a rectangular table. So let's first understand what this problem is saying. We have 4 seats. They are on a table. And this is a rectangular table because these people are sitting on the one side of this table. For example, person P1 is sitting here, P2 is sitting here, P3 is sitting here, P4 is sitting here. And we would like to find the total number of arrangement where we can basically shuffle these people on these 4 seats. So as you can see that all the 4 people are the distinct object, and once we put one person on a one seat, we cannot put that person on the second seat, so the repetition is not allowed. So in this real world problem, there is no repetition, and order is being important, because if I place somebody in the first position, second position, third position, and fourth position, versus I place somebody on the fourth person places on the first position, on the second position I will place the third person, and in the third position I will place the second person, and the fourth position I will place the first person. This will be a two different arrangement, so it will not be a same arrangement. So the order is matter. So we can solve this problem by using the formula of permutation, which is um, we have four people and we have to arrange them on four places, and these four people are distinct, they are not same. If these people are identical, then we won't be able to use this formula. The formula is a 4 factorial, which we know that it is a 4 times 3 times 2 times 1, and which is basically is equal to 24. So there are 24 different way to arrange these four people at a 4 seat of a rectangular table. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Our example number 3 is how many way 3-letter word can be make out of A, B, C, D, E, F, G. So there are 7 English letter A to G, and we have to arrange 3 of them. So this problem of is also permutation, but it is a little different problem. So in this case we have the letter A, B, C, D, E, F, and G, and we need to pick at a random the 3-letter. For example, if I pick let's first 3-letter, and then I find all the permutation of these 3-letter, and then I pick another 3-letter, let's suppose A, B, and D, and then I find all the different permutation. Or I pick B, C, D, and find all the different arrangement. So you can see that there are too many arrangement which basically we cannot even list here. So there are too many arrangement, we can't be able to list all here. So let's find a mathematical way to solve this problem and trying to find the formula. Again, I said this permutation is a sub case or a particular case of a product rule. So we can use the product rule to find the formula for this special type of arrangement. So let's write down this problem in terms of a product rule. So we know that when we use the product rule, first we try to find what is the procedure. So as you can see in the procedure is we have to arrange 3-letter, 3 character or 3-letter. If I want to arrange 3-letter, it means I need to complete 3 tasks, and I need to, this is my first place, this is my second place, and this is my third place. So I need to basically place 3 character on the first place, and then the second place, and then the third place. So these are my tasks. So now let's find out how many way I can complete my first task and then second and third. So as you can see, I have 7-letter, so I can complete my first task 7 different way. So I can pick any letter out of 7 and place in the first position. Since the repetition is not allowed, the second task can be complete in 6 way, because once I use the letter at the first place, I cannot use it again. So there are 6 different way to complete the second task, and there are 5 different way to complete the third task, because I cannot use the letter which I use in the first place and I use in the second place. Next, let's find out what is the conjunction. So as you can see, conjunction is the same and, because I have to complete all the 3 tasks simultaneously. I have to place the letter in the first position, and I have to place the letter in the second, and I have to place the letter in the third position. So therefore the total number of arrangement will be 7 times 6 times 5. So if we have to write down in a notation form, because this is a permutation, I will say that I have 7 letter. So I have 7 object, and I place these 7 object into 3 places. So this is the notation. So these are the 7 distinct or different object, and they have been placed into the position. So this is the position, and this is a object. So this is how basically you want to think of this problem. So you have the distinct object and they have distinct position. And this is given by 7 times 6 times 5. And also you see there are 3 natural number which are multiplied together. And this is also sort of somehow related to that. So if you have to write it on a formula, you can think is of that you start from the object and you write these number in a descending order, keep subtracting 1, and you write the total number of positions. So this is how you can think of this formula. Let me write this formula in term of also factorial. So how to write this formula in term of a factorial? So what I can do is I can write 4 here, 3 here, 2 here, and 1, and then I divide with the same number, 4, 3, 2, and 1. So if I do that, I can see that the top is 7 factorial. That was the definition of 7 factorial. It's starting from 7 and going to 1. It is the multiplication of all the natural numbers starting from 7 to 1. 7 factorial. This one is 4 factorial. And there is another way to write this thing. 7 factorial. Whole thing is a divide by 7 minus 3 factorial. So why I would write in this formula, because you see that I have 7, the number of object, I have a number of positions and a number of objects. So this sort of formula can be generalized. So the general formula, I can write it as, if I have an object and I have to place into, for example, m position, then the formula will be n factorial divided by n minus m factorial. So m has to be less than n, because n is less than or is equal to m. And also you can notice that if n is exactly is equal to m, then this formula will give you the formula which I showed you in the previous slide, that the permutation. The n object places into the n position will be exactly is equal to the n factorial divided by 0 factorial, which is equal to the n factorial. So here is the summary of these two formulas. So if we have the n number of position and n object, so then the formula will be n factorial. If you have n object and r position, then the formula will be n factorial divided by n minus r factorial. Let's solve one more problem and we will utilize these formulas which we discussed in the last slide. So our example number 4 is, how many possibility are there for the win, place, and show first, second, and third positions in a horse race with the 12 horses if all the order of the finish are possible. So as you can see that we have 12 horses. So this problem is saying that 12 horses and there are 3 win position. So this is the first position, this is the second position, and this is the third position. First, second, and third. So as you can see that this problem is of a permutation problem. We have to pick the 3 horses and we have to place into the first position, second positions, and third position, and we need to basically find how many way we can arrange them. So how many permutations are there. So this is a problem of a permutation where we have the 12 distinct object, because there are 12 horses and we consider all the horses are distinct, they are not identical, and we have to place into the 3 position, the first position, second position, and the third position. So therefore by the formula of the permutation, it will be a 12 factorial and divide by 12 minus 3 factorial. So therefore this is a 12 factorial divided by 9 factorial. And if you write down, this will be a 12 times 11 times 10. So this will be a total number of permutation will be 1, 3, 2, 0. These are the total number of permutation in this case. Okay, this is also the end of this video. Thank you very much for watching. I will see you in the next video.